Good day, everyone. We are from Group 6. We'll be presenting disruptive innovation in sustainable products using rice husk. Our members are Muhammad Shamil, Muhammad Fakrul, Muhammad Kamil, Janaga Shakti, and Siti Tulaika. My name is Janaga Shakti. So, what is rice husk? Rice husk is an outer shell removed during rice milling, which is produced in a very large amounts, rich in cellulose, lignin, and silica. Rice husk can be converted into biofuels to generate renewable energy, bioplastic into biodegradable plastic, activated carbon to remove impurities in water or air, and also construction materials to produce eco-friendly, lightweight building products. How can it be converted? First, biomass conversion using fermentation or pyrolysis, thermochemical processes, heat to energy or materials, and also silica extraction for industrial use in cement, electronics, and etc. What product does it potentially replace or disrupt? Number one, fossil fuels. It replaces petrol and diesel to reduce carbon emissions. Number two, plastic products. It replaces petroleum based plastic to biodegradable alternatives. Number three, wood and construction materials. It replaces wood and partially cement to reduce deforestation. And number four, chemical silica. It replaces mined silica to more sustainable source. These products uses waste, which is a very low cost raw material, and promotes circular economy, reduces reliance on non-renewable resources.
Assalamualaikum and hi, my name is Muhammad Kamil Syed bin Amrad. My metric number is A203149 and I will talk about the sustainability of rice husk. First, rice husk can be considered as renewable sources where it can be utilized in the production of sustainable eco-friendly food packaging, and then it can be used in the production of lightweight construction materials, and it also support the circular economy where agriculture waste can turn into useful products. For carbon footprint, rice husk generally has low carbon footprint because CO2 release are equivalent to CO2 absorbed during the photosynthesis, and rice husk can reduce 30% of CO2 greenhouse emissions when being utilized in the construction, and rice husk energy sources can reduce 60% of carbon emissions. For biodegradability, products made from rice husk are generally biodegradable as 80% of its components are organic. Material with higher percentage of rice husk has good biodegradation ability. For disruptive and innovation, rice husk can be considered as a disruptive innovation in certain markets because it has evolved from agricultural waste into available resources. Today, it is widely used in industries such as construction, agriculture, and biomass energy generation. Because it is a low cost, abundant, and versatile, rice husk can replace some conventional materials and potentially change market dynamic. At the same time, it is also an innovation because it transforms waste into useful products. With more than 150 million tons of rice husk waste treated, it can be converted into products for energy, medicine, and construction.
Now, let's look at the benefit of rice husk as a sustainable material from three perspectives: consumer, industry, and the environment. First, for consumer, rice husk-based products are more eco-friendly compared to conventional plastic. They are generally non-toxic, safe to use, and suitable for daily application such as a packaging or household item. In addition, these materials are lightweight and biodegradable, which make them more sustainable in the long term. Next, for industry. Rice husk is actually a very cost-effective raw material because it is an agricultural waste from rice production. Instead of being discarded, it can be converted into useful product. This helps industry reduce their dependence on petroleum-based material. Moreover, rice husk can be applied in many sectors, including construction, packaging, automotive, and even energy production. Lastly, from an environmental perspective, using rice husk helps reduce open burning, which is a major source of air pollution. It also lowers the overall carbon footprint footprint and reduce landfill waste since it's biodegradable. Overall, this supports the concept of circular economy, where waste is turned into valuable resources. Despite its many benefits, rice husk also comes with several challenges and limitations that prevent it from being widely used globally. First, in the term of technical challenges, the quality of rice husk can vary depending on the source, which affect the consistency of the final product. It also requires specific processing technologies, such as silica extraction and material treatment, which can be complex. In some cases, rice husk-based material may also be less durable compared to conventional synthetic material. Secondly, there are economic and market barriers. Although the raw material itself is cheap, the processing and production costs can be relatively high, especially at the very earliest stage. In addition, not all countries have the infrastructure to support large-scale production. Conventional materials like plastic are still cheaper and more established in the market, making it difficult. Finally, adoption is another issue. Many consumers and industry are still not aware of rice husk-based products, and there is often resistance to change. There is also a lack of global standard and regulation for this material. So overall, while rice husk has strong potential, it is not yet used globally due to technological, economic, and market challenges.
Next, I'm going to explain the market potential of rice husk in disruptive innovation. First point is scalability. We can see that rice husk is a widely available agricultural byproduct, which make it abundant and also scalable resource for various applications. This jump into the second point, which is the diverse application. We can see that rice husk can be used in renewable energy production, construction materials, and also industrial uses. Lastly is the energy potential. We can see in countries like Indonesia and Cambodia, rice husk can generate a significant amount of electricity, indicating its scalability for energy production. Second point is adoption resistance. We can see from the lack of awareness in certain regions, rice husk can perceive as a waste and also leading to it not utilized effectively. Second point is technical challenges. We can see that adoption in advanced applications such as biochar may face resistance due to the need of specialized equipments. And lastly, compatibility issues. Sometimes rice husk have poor compatibility with host matrices. This requires additional research and treatment, which could also slow down the adoption. And last point is the cost issues. Rice husk is a low raw material cost, which make it economically attractive for energy and material application. And second point is cost effectiveness in energy. Study shows that the rice husk based power generation has a shorter payback period, which is 6 months for boilers, compared to coal and also furnace oil, making it cost efficient alternative. And next is economic viability. The sale of carbon credits and reduce fossil fuel dependency further enhances economic feasibility, with projects showing up to a 50% increase in viability. And lastly, the challenges in processing. Some applications such as activated temperatures, high activation temperatures, and specific chemical treatments can increase the cost.
Hi everyone, my name is Muhammad Syamil Idlan. Today I will talk about how our Rice Husk project align with the global sustainability goals. First, this innovation support three main United Nations SDG. As first, SDG 7, we produce renewable bioenergy from rice husk. Next, SDG 12, we practice a circular economy by turning waste into available resources. Last, SDG 13, we help to reduce greenhouse gas emission to fight a climate change. Okay, beyond that, we are integrating into the bioeconomy We take algae culture biomass and turn it into a high value product and making our resource use much more efficient. Finally, for Malaysia, this project is very relevant because it aligns with our national bioeconomy policy and help to reduce the burden of managing algae culture waste. It is a big step toward green technology. Now, let's take a look at the big question. Should rice husk be adopted globally? The answer is yes, but with a strategic plan. But why? Because rice husk is an abundant and renewable resource. It offers proven environmental benefits like being low carbon and biodegradable. Plus, it can be used in a many industry, from energy to construction. However, we must face some critical insight. To succeed globally, we need a better technology, a stronger policy incentive, and a better infrastructure. We also need the market to fully accept this new material. So, in conclusion, rice husk is a high potential biotech innovation. Its global success depends on how well we integrate technology, policy, and industry readiness. I think that's all from me. Thank you.